Hello everyone, welcome back. In this video, we'll learn how we can do interfacing of DHT22 or DHT11's temperatures and humidity sensor with Arduino. So let's get started. We have two types of DHT sensor. One is DHT11 and another one is DHT22. So there are some difference between these two modules. Let's discuss them. The first one is DHT22. It's also known as AM2302 model. The temperature range for DHT22 is minus 40 degrees centigrade to 80 degrees centigrade. But for DHT11, this is a shorter range from 0 degree to 50 degrees centigrade. So if you're working on application that is at room temperature, then you can go for DHT11. And if you are working on application where some refrigeration or high temperature is involved, then you should go for DHT22. Then the humidity range for DHT22, it's 0% to 100% relative humidity, whereas for DHT11, it can measure 20% to 80%. Temperature accuracy is 0.5% plus minus, whereas in 22, DHT11, it is plus minus 2 degrees centigrade. Accordingly, relative humidity is plus minus 2% for DHT22 and 5% for relative humidity. Now, communication interface. The DHT22 and DHT11, remember, these are digital output from this. We get digital output from this sensor. So do not connect the output from DHT22 or DHT11 to analog input pin of Arduino. Instead, we need to connect this pin at digital input. Supply voltage, we can supply 3.3 volt to 6 volt. And for DHT11, it is 3.3 to 5.5. Sampling rate is 0.5 Hz, that means 2 seconds between reading. And for DHT11, it is more faster, 1 second between reading. Response time is 2 seconds for both. Resolution is 0.1 degree centigrade and 0.1% RH. But the DHT11 has lower resolution, that is 1 degree centigrade and 1% RH. Both has similar pin like VCC, ground and data pin. Compatibility. Commonly used, widely available, and DHT11, this is the cheaper one. This is also commonly available. Typical use case, the DHT22, these are basically used for weather station, indoor climate monitoring, and refrigeration projects, and so on. But DHT11, this is simply just for environmental monitoring, because the temperature it covers is in between 0 degree to 50 degrees centigrade, which is normal environmental temperature. So that's all for the features and the description of DHT11. Let's look at the connection diagram. The connection diagram is pretty simple. The positive supply of DHT, we need to connect it to 3.3 volt or 5 volt. The ground, we need to connect it to ground. The output signal pin of DHT sensor, we need to connect it to any of the digital pin of Arduino. Now let's come to the programming part. The first part is we need to include DHT library. There are several libraries available for DHT sensors. Whatever library you use, you will have to program accordingly. More or less, the steps are similar for all libraries. The first step is to include the library using #include. Then we need to create a DHT object. The way of creating a DHT object is first we need to define DHT pin, DHT type. You can skip these two lines if you put manually the values here, like DHT, we need to type in first DHT in capital letter. Then you can give an object name like DHT1, DHT2 or whatever you want. Then at the place of DHT pin, you need to define which pin you are using for DHT input and DHT type, whether it's a DHT11 or DHT22. So you need to define that here. The third step is initialization. In the void setup configuration, you need to write DHT.begin. So this will initialize the DHT sensor. The next part is taking reading from the sensor. As the values will be having some decimal values, you can use float for that. So float temperature, we need to first write the object name, that is DHT. Dot read temperature is the function for reading temperature, and read humidity is the function for reading humidity using this DHT.h library. For other libraries, this command or the function name could be different. Now once we have the read value of temperature and humidity and stored in two variables like temperature and humidity, these two variables, we can print the value using any of the medium like serial monitor. We can use LCD display, we can use OLED display, or anything like that. So that's all for the programming steps. Let's jump into the OQI and let's see how we can do this in simulation. We have come into OQI. Let's bring in the DHT sensor, DHT. So this is the sensor. In OQI, DHT11 is not available. The DHT22 is only available here. The first pin is for VCC. So let's bring it here. Let's connect the VCC to, you can connect it to 5 volt or 3.3 volt, doesn't matter. Then let's connect the ground to ground. Now there is another pin called NC that is not connected, and another pin is called data. So let's connect the data pin to pin number 2. This will be all for configuration of DHT with the Arduino connection. Let's do the programming part. The first step is including the library. Let's do that. Include DHT. So this DHT.h, this is the sensor we are looking for. We will also add the sensor at the library manager. Let's do that. DHT. The DHT sensor library is the one that we are working for. So let's connect that. Now the second step is creating a DHT object. To create DHT object, we need to write DHT, then DHT. You can give any name like DHT1, DHT2, or whatever you want. Then you need to first write which pin you are using for DHT input. Like we have used the pin 2, so you need to tell this one here. And what type of DHT module you are using. We are using DHT22. So this is how you can create a DHT object. Now in the void setup part, we need to initialize the DHT, that is the third step. So you can write DHT.begin. So this will initialize the DHT. Now if you are looking for serial monitor printing, you can initialize that also. Serial.begin with baud rate of 9600. From void loop, you need to do the following steps. We need to do the next step, that is reading the temperature. So let's bring in a float variable for temp for temperature, and bring in another variable for humidity, that is hum. Now there is two functions available for reading temperature and humidity. DHT.read temperature, then semicolon. In the similar manner for humidity, DHT read humidity. Okay, so that's all for reading temperature and humidity. Now let's do the printing, that is the final step. Let's do serial.print. We want to first give a message like temperature. Then we want to print the temperature value. So write serial print. And here we need to define the variable, that is the temp. We need to write temp here. So this will print the temperature. And we want to print the humidity also. Let's give a escape sequence, like let's give the space of horizontal tab, and let me copy this 3 line. The next one, we want to read humidity, then the variable would be hum, and next we want to give a escape sequence of new line. So this will be all for printing the values. You can also give some degree centigrade and percentage humidity symbol like that. Let's give it here, percentage, and before temperature, let's say Celsius, degree Celsius. Okay, don't forget to put a delay here so that you can make some stable reading. Let's make a delay of 1000 millisecond or 1 second. Okay, let's run the program. That's all for the programming. Let's run the program from simulation. So here you can see the temperature sensor is 20 degrees centigrade, 20 degrees Celsius, and the humidity is 40%. Let's change the values from temperature and humidity, clicking on this sensor. Let's bring it the temperature to something like 40 degree or 39.1. So you can see the reading has been changed. Let's change the humidity also. Humidity has been updated here. So this way we can do temperature and humidity based projects where we can read temperature and humidity reading and do conditional applications, like we can use temperature and humidity for environmental monitoring. We can make control environment using DHT22 sensor. We can control cooling fans using DHT22 sensor, and projects like that. Wherever temperature and humidity is involved, we can use this sensor with Arduino and do some activity based on that. I hope you got the idea how to interface DHT22 with Arduino. So that's all for this video. We'll see you in the next video.